Okay, in this video, we're going to learn how to convert polar coordinates to rectangular coordinates and vice versa. All right, so we're going to also learn how to convert from rectangular to polar coordinates. Okay, let's start with what to do or what tools do we need to make the conversion from polar coordinates to rectangular coordinates. All right, for this, we're going to use two formulas that you probably know. And the first formula is that x, right? Because we know that rectangular coordinates are made as x and y. And we know that polar coordinates are made as r, radius, and theta, right? And to find the value for x, all right, when we have this information, we're going to do it like this. X is going to be equal to the radius times cosine of theta, okay? And y is going to be equal to the radius times sine of theta. Okay, so let's suppose that we're trying to convert this polar coordinate to rectangular coordinates. Maybe we have the polar coordinate 2 and 3 pi over 2. So we know that this is r, we know that this is r, and we know that this is theta. Okay, so let's convert, or let's get the value for x first. So we have that x is going to be equal to the radius times cosine of theta, but we know the radius 2 is going to be multiplied by cosine of 3 pi over 2, right? Since 3 pi over 2, we have to evaluate cosine of 3 pi over 2. So if we're trying to evaluate that, we know that in the unit circle, 3 pi over 2 will be, this is pi over 2, this is 2 pi, 2 pi, 3 pi over 2. And in here, we have the terminal point 0, negative 1, right? That's our terminal point for 3 pi over 2. And we know also that in here, cosine, the value of cosine is x. And this is x, and this is y. So we know that the value for cosine of 3 pi over 2 will be x, that is 0. So this is equal to 2 times 0. And you can check that in your calculator if you want. 2 times 0 is 0, right? So we have the value for x, right? So we know that this polar coordinate as a, and let me move this real quick. This like two in the middle. And we know that for this polar coordinate in rectangular coordinates, the value for x is going to be 0. And we're going to find the value for y. So y, it's going to be equal to 2 times sine, look, sine of theta, right? So 2 times sine of 3 pi over 2, right? So this will be equal to 2 times whatever value we get from sine 3 pi over 2. And 3 pi over 2 is the same angle that we analyzed before. And we know that sine, it's the value for y, and y is negative 1. So it will be 2 times negative 1. And 2 times negative 1 will be negative 2, right? So the value for the y coordinate here will be negative 2. My bad, negative 2, right? So our polar coordinate 2 and 3 pi over 2 with this direction will be in rectangular coordinates as 0 and negative 2, 0, negative 2, okay? This will be our conversion. All right, let's try to do it again and see how it goes. Let's suppose that we are trying to convert the polar coordinate 1 and 5 pi over 6 with this direction. Okay, and again, we know that x will be equal to r, that in this case is 1, times cosine of 5 pi over 6, 5 pi over 6. The value for 5 pi over 6, let's do it here. We know that 5 pi over 6, it's here, right? Oops, it's around here. This is 5 pi over 6. We know that the signs for this are all students take calculus. So we know that cosine is going to be negative. Cosine is going to be negative is here. So we know that it's going to be negative. And our reference angle here, it's pi over 6. So this cosine 5 pi over 6 is going to be equal to negative cosine of pi over 6. And we know that cosine of pi over 6, so this will be equal to negative cosine of pi over 6, that is square root of 3 over 2, right? So this will be equal to 1 multiplied by this value. So negative square root of 3 over 2, that it's equal to negative 3 over 2. So we know that this, and let me use a different color. So we know that this can be written as a rectangular coordinate like this, negative, right, 3 over 2 with the value of y. What will be the value for y? Well, we need to basically repeat this process. So y, it's equal to 1 times sine. This time we'll do it with sine. Sine 5 pi over 6. If we do the same analysis, let's erase all this for cosine. We know that sine is going to be positive in this quadrant. And this we will use the same reference angle. So sine of 5 pi over 6 will be the same as sine pi over 6. And we know that sine pi over 6, it's 1 over 2. So this is going to be equal, this is equal to 1 over 2. So our rectangular coordinate will be negative square root of 3 over 2 and 1 over 2. This will be our coordinate, rectangular coordinate, if we convert it from this polar coordinate. All right. So that is the idea on how to convert from polar coordinates to rectangular coordinates. All right, let's do it backwards. If we want to go from rectangular coordinates to polar coordinates, we're going to use 2 different formulas. We know that we need to find, we have this, we have x and y, right? And we need to end up having a radius and direction, a theta, an angle, right? So we know that the radius can be found with this formula. Radius squared, it's equal to x2 plus y2, right? We know this. Why? Because if we have a radius, let me do it real quick. If we have a radius, this is our radius, we can define a height, right? We can make like a right triangle, and the height can be, we can call it y, and this base right here, we can call it x, right? So since this is a right triangle, we can apply, and remember this is the radius, we can apply the Pythagorean theorem, and obviously we will get this for the radius. Okay. Now, so now with this one, actually we can even rewrite it like this, right? We can rewrite it like this immediately. And we know that in that way we can find the radius. And for theta, we know that the only, if we have the same thing, my bad, I erased it. But if we have the same triangle, so this is R, this is Y, and this is X. If we have the same triangle and we're trying to find this angle, right? The only trigonometric ratio or function that relates x and y, that will be the only information that we'll have from a rectangular coordinate, is going to be tangent. Why tangent? Because tangent of the angle is going to be equal to opposite, that is y, over adjacent, that is x, right? And let me write this with a different color. So tangent of theta will be equal to y over x. So with these formulas, we can find the radius and we can find theta, because if you isolate theta in this case, you will have that theta is going to be equal to inverse tangent of y over x. So with these 2 formulas, we can find the polar coordinate. So let's do an example. Let's suppose that we're trying to convert negative square root of 2 and square root of 2 to polar coordinates. All right, we're doing this. Okay, remember that. All right, so we know that this is x, right? So we know that this is x, and we know that this is y. Okay, so let's find the radius first. To find the radius, we're going to do it like this, right? X to the power of 2, so we have negative square root of 2 to the power of 2, plus the value for y squared. Look, the value for y squared. So we're going to do square root of 2 to the power of 2. Okay, so we have the square root here. All right, so if we do the power, this will be 2. So we have square root of 2 plus, same goes here, we cross out and we get 2. And 2 plus 2 will be 4. And the square root of 4 will be 2. So now we know that the radius it's 2. right? So if we're converting this, to polar coordinates, the polar coordinate will be radius 2, and let's find theta. To find theta, we already know that we're going to use this little formula. All right, so let me erase this. We already have this information. So, okay, so we're going to use the formula to find the value for theta. So theta is going to be equal to the inverse tangent of y, that is square root of 2, over negative square root of 2. But square root of 2 over square root of 2 is 1. So we have, this is basically inverse tangent of negative 1, right? Negative that is left with this one, right? Okay, so how do we find that value? Remember that when we have this, what we're looking for, it's tangent of an angle that will give us negative 1, right? That is what we're looking for. Now that we know what we're looking for, remember that if you have the coordinate plane, right? If we're going to evaluate it, I mean, if you know it by heart, then you just find the angle and that's it. But how do we get negative 1 for tangent? We know that all students take calculus. So these two are positive and we're looking for a tangent that is negative. So it cannot be here. So it must be in between these two. Since we're looking for an angle on a polar coordinate, then we know that the only angle that will give us negative 1 is going to be 45 degrees, because we know that tangent is opposite and adjacent. So 1 divided by 1, it will be 1. So we need an angle in which the reference angle is 45 degrees, or in other words, it will be pi over 4. That angle will be right here, right? The reference angle will be here next to the x-axis. So this will be pi over 4. And if I divide everything by 4 and I'm left, and I have 1 left, then I'm taking 3. So this will be 3 pi over 4. So my angle, after all this analysis, my angle will be 3 pi over 4 to be able to get negative 1, right? So theta, so in this case, theta will be equal to 3 pi over 4, okay? 3 pi over 4. And if this is the case, then, or theta for the polar coordinate, if the rectangular coordinate is negative square root of 2 and square root of 2, will be 2 and 3 pi over 4. I know it can be tricky sometimes, but if you think about it, it's not that hard. Okay, if you know how to evaluate trigonometric functions and you know how to evaluate inverse functions, it's actually not that hard. Okay, let's do one more example. Okay, so let's try to convert from rectangular coordinates 3 square root of 3 over 2 and 3 over 2 to polar coordinates, right? So we're looking for polar coordinates. Okay, so let's find r first. So if we find r, let's do it here. R is going to be equal to the square root of x to the power of 2. So 3 square root of 3 over 2 to the power of 2 plus y to the power of 2. So 3 over 2 to the power of 2. Okay, so we have this. All right, so 3 to the power of 2 will be 9. Square root of 3 to the power of 2 will be 3 times 3. And 2 to the power of 2 will be 4. Plus 3 to the power of 2 will be 9. 2 to the power of 2 will be 4. We know that 4, well, this is the square root. 4 times 3, it's 27, right? 27 plus 9 will be equal to 36. So we have the square root of 36 over 4. The square root of 36 over 4 is 9. So the square root of 9 will be 3. R will be equal to 3. So we have 3 for our radius. All right, let's find theta. So we know that theta is going to be equal to, let's do it with another color. So theta will be equal to inverse tangent of y, that is 3 pi over 2, over x, that is 3 square root of 3 over 2. All right, we know that we can cross out these 3's we can cross out the 2's, and we get that inverse tangent, it's going to be equal to 1 over the square root of 3. 1 over the square root of 3, right? Because if we cross out 3 over 2 and 3 over 2, then we're left out with 1, right? Because 3 over 2 divided by 3 over 2 is 1. So, and this can be rewritten as inverse tangent of square root of 3 over 3. When do we get 1 over the square root of 3 or square root of 3 over 3? Well, remember that we are looking for an angle evaluated, a tangent in tangent that is equal to a square root of 3 over 3 or 1 over 3. It doesn't matter. It's basically the same thing. So if we go and let's erase this, we already know what R is. All right, we need to think. When do we get 1 over the square root of 3? If we go to our 60, 30, 90 angle, this is 1, this is 2, and there's the square root of 3. When do we get that the opposite, because remember that tangent is opposite, and over adjacent, when do we get that the opposite is 1 and adjacent is square root of 3? For which angle, basically? We know that this happens for this angle, right? 30 degrees. Why? Because opposite is 1 and adjacent is square root of 3. So it will be 30 degrees. That in radians will be pi over 6. Pi over 6. All right, so theta will be pi over 6 for this value. So this theta will be equal to pi over 6. Now, if we go back to our polar coordinate, then this rectangular coordinate will be equal as a polar coordinate as radius 3 and theta pi over 6. All right, that's how you convert the polar coordinates. It's really important, again, that you know how to evaluate trigonometric functions and inverse trigonometric functions. Okay, I hope that with these 4 examples, you're able to understand how to do it. So my advice to you is that you practice. So you can learn this topic. All right, see you in the next one.